Imagine an object accelerating from a standstill to over 50 miles per hour in less than 3 thousandths of a second. The force involved is over 10,000 times the force of gravity, an acceleration that rivals a .22 caliber bullet leaving a rifle. Now, imagine this isn't happening in the air, it's happening underwater, a medium 800 times denser than air. This isn't a piece of advanced machinery. It is the dactyl club of the peacock mantis shrimp, a biological hammer moving so fast that it fundamentally changes the water around it. A simple muscle contraction, no matter how powerful, cannot generate this kind of speed. The secret lies not in the muscle itself, but in a piece of anatomy that functions like a spring-loaded crossbow. The shrimp uses its muscles slowly to deform a saddle-shaped structure made of biomineral. Think of it like compressing an incredibly stiff spring. This saddle, located in the upper part of the limb, stores an immense amount of elastic potential energy, held in place by a tiny latch. The muscle's job isn't to create the speed, but to load the weapon. The strike itself isn't a push, it's a release. The latch gives way in a process of controlled mechanical failure, and the stored energy is unleashed all at once. This is an over-centering mechanism, similar to the satisfying click of a light switch, where a small movement triggers a sudden, complete change of state. The appendage rotates with such violence that it reaches a top speed of 23 meters per second. At this velocity, the laws of fluid dynamics begin to break down in a very specific and violent way. When the club moves that fast, it pushes water out of the way faster than surrounding water can fill the space. This creates a pocket of extremely low pressure directly in front of the club. Pressure and boiling point are directly linked. If you lower the pressure enough, water will boil even at room temperature. For a fraction of a second, the water in the path of the strike literally boils, creating a bubble not of air, but of water vapor. This is cavitation. This bubble of vapor is incredibly unstable. As soon as the club's motion is complete, the immense pressure of the surrounding ocean rushes back in to fill the void. The bubble collapses on itself with catastrophic speed and force. This collapse isn't gentle. It is a focused implosion that generates its own set of extreme physical phenomena. The cavitation bubble is not a side effect of the punch. It is the second and sometimes more devastating part of the attack. What happens when you compress a gas very, very quickly? It heats up. The vapor trapped inside the cavitation bubble is compressed so violently during the collapse that its temperature skyrockets. For a nanosecond, the point of collapse reaches several thousand degrees Kelvin, momentarily creating temperatures that approach the surface of the sun. This intense heat produces a tiny, brilliant flash of light, a phenomenon known as sonoluminescence, and an audible pop. The shrimp's punch creates a tiny, temporary star. A target, like a crab's shell, is therefore hit twice by a single motion. First, there is the initial physical impact from the club itself, which is powerful enough to shatter shells. But milliseconds later, the shock wave from the collapsing cavitation bubble slams into the target. This secondary impact can carry as much force as the initial physical strike, ensuring that even a near miss can be debilitating or lethal. It is a 1-2 punch delivered with the physics of a collapsing star. This raises a question. How does the club itself survive these repeated, self-inflicted impacts? The material science is as sophisticated as the mechanics. The club's surface is made of a dense, highly crystalline form of hydroxyapatite, the same mineral in our bones and teeth, but much harder. Beneath this impact layer lies a softer region composed of chitin fibers, the same material in insect exoskeletons. These fibers are arranged in a helical or spiral pattern known as a boulagon structure. This structure is brilliant at dissipating energy. Instead of a crack propagating straight through, it is forced to twist and turn, spreading the impact force over a larger area and preventing catastrophic failure. To aim such a complex weapon requires an equally complex visual system. While you have 3 types of color-receptive cone cells in your eyes for seeing red, green, and blue, the mantis shrimp has between 12 and 16 distinct photoreceptors. But this does not mean they see a rainbow of unimaginable new colors. In fact, their ability to distinguish between subtle shades, like light orange and dark orange, is actually worse than ours. Their visual system is not built for richness, but for speed. Your brain does a lot of work to interpret color. It takes the signals from your 3 cones and computes the result. The mantis shrimp's brain appears to do very little processing. Instead of computing color, each of its 12 photoreceptor types is tuned to a very specific wavelength of light. Its eye functions more like a scanner or a spectrometer, instantly recognizing a color without needing to think about it. This allows for near instantaneous identification of prey, predators, or mates, a crucial advantage when your primary weapon moves faster than thought. Beyond color, their eyes perceive a property of light that is completely invisible to us: polarization. They can see linearly polarized light, like the glare off of water, but they are also one of the only known animals that can see and manipulate circularly polarized light. This is a rare form of light where the light wave's oscillation travels in a spiral. Certain species of mantis shrimp have body parts that reflect light with circular polarization. What does this mean? It means they have a secret, high-contrast communication channel. It's like wearing a pair of special glasses that reveal hidden messages, making them stand out vividly against any background, visible only to those with the right equipment. None of these features exists in isolation. They form a single, terrifyingly effective system. The saddle stores energy that muscles alone could never provide. The strike moves so fast it weaponizes the physics of water itself. The resulting shockwave acts as a secondary weapon, ensuring a kill. The composite armor of the club withstands forces that would shatter bone, and the hyper-specialized eyes guide this entire sequence with a speed of recognition that bypasses the need for complex thought. It is a portrait of an alternative path in evolution, where biology has mastered extreme physics.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.